Here in these slides, we will see which encoding scheme is best, or how to compare the different encoding schemes that we have seen, or how a designer wants us to choose these different schemes. So what are the different factors he needs to consider? So the first one is signal spectrum. That means the bandwidth occupation. So when we try to transmit these signals, they occupy some bandwidth in our transmission system. So we know the frequency. They use some frequency. So the more bandwidth they occupy, it is the worst scheme that we can say, because bandwidth is a limited resource. So we want to minimize as much as possible this bandwidth, and or conserve the bandwidth and minimize error. This is our aim in signal transmission, analog or digital signal transmission. This is our aim or goal. So we want to use as much as possible less bandwidth to send the same amount of data using the different encoding schemes. So the next one is clock or synchronization. So that means the transmitter signal can be used by receiver and know where a bit ends and the next bit starts. So the other one is error detection. So there are some encoding schemes that are inbuilt error detection mechanism. In bipolar AMI and zero ternary, we can find this error detection. So some encoding schemes work better also with higher noise or with signal interference, and some have high cost and complexity. So when we see the differential and Manchester and differential encoding, they are more complex because they have more transition in the signal element, right? In their bit there are more signal transition, but whereas in other encoding schemes there are less encoding schemes, so that makes it complex and costly. And let's see a diagram for this bandwidth occupation. So in this diagram you can see Manchester and differential Manchester encoding occupy large bandwidth. So they are, in terms of the bandwidth occupation, they are the worst, but in terms of this synchronization, they are best encoding scheme. So this AMI and zero ternary are based in bandwidth occupation. So they occupy only one. This is frequency plot for the different encoding schemes. So you can see by this diagram we can compare the different encoding schemes here. So this bipolar AMI and zero ternary, they are called multi-level binary schemes because they have three levels: positive, zero and negative. And we have biphase schemes. This Manchester and differential Manchester, there are more transition per bit, and they have multi-level schemes but larger bandwidth are required. So here we require only small bandwidth. So this is some comparison between the different encoding schemes. So there are different technologies using these encoding schemes, and by this we will end the first part and go to the second part, that means digital data as analog signal. So in case of digital data analog signals, we have bits to send, but now we have a continuously varying analog signal to transmit. So there are three basic techniques as we discuss later. So we have a sequence of bits, that means our digital signals, 0 1 0 1 0 1. So let's see the example directly. So we have this digital data, 0 sequence of bits, zeros and ones. So this is our digital data. Then we want to send as a form of analog signal, continuous varying analog signal. So this is the digital data we want to send, but we need to send an analog signal that we know. So how can we change the shape of the analog signal? So to change the shape of analog signal, we say that we should vary the amplitude, the phase, and the frequency, because these are the three basic components of analog signal, sinusoidal signal. So let's see the first one, the amplitude shift keying. So here we vary the amplitude, the frequency and the phase are fixed, and when we have a bit 0, send a 1 amplitude, and in this example amplitude may be 0, the magnitude is 0, and when we have a bit 1, transmit an analog signal, in this case, in this example, a different magnitude amplitude, let's say +1. So think this flat line is a sine wave with 0 amplitude, which is 0 signal with 0 bits or 0 data, which correspond to 0 bits, and this one change the amplitude depending upon the bit. So when you receive this signal again, then we can get the digital data. So when you get bit 0, constant sine wave. When you get a bit 1, a normal sine wave with +1 amplitude. So the amplitude, we vary the amplitude or we change the amplitude depending upon the bit. So when we receive this signal again, we have a signal element duration. If the signal is 0 volt for this duration, data means amplitude is 0, that a bit received is 0. If the signal amplitude is 0, in this case +1, then it corresponds to a bit 1 received. So shifting the amplitude of the analog signal based upon the bit that we want to send. The amplitude does not have to be 0 in this example. It is 0, maybe 0 or non-zero, +1, +2. For example, to send B0, we can make it +1 amplitude. To send a bit 1, digital data bit 1, +2 volts. We can do like that with 2 non-zero values. The next one is by varying the frequency or frequency shift keying. So instead of changing the amplitude, change the frequency. So B means binary, which means there are 2 levels of frequency, binary for 2, B. When we have a bit 0 to send a signal at 1 frequency, let's say we have 1 repetition per interval, so we have 1 Hz. To send a bit 0, we use 1 Hz. When we have a bit 1, change the frequency, high frequency, we have 2 repetitions, so we will send it the data bit 1 as 2 Hz volt or 2 Hz frequency, so 2 repetitions in 1 interval. So this is just an example. The concept is change the frequency which is dependent upon the bit transmitted. Low frequency for a bit 0 and low frequency for a bit 0 and high frequency for a bit 1. And of course we have phase shift keying also. Bit 0, in this case we send with a phase pi from bottom to up. We go down then up, so we start going down and up this. So the amplitude and the frequency are the same, but the phase is changed. So when we want to send a bit 0, we send it with a phase pi. Then when we have a bit 1, we send at the normal phase phase pi, phase 0 with a phase 0. That means we get from normal go up and down. So frequency and amplitude are the same. So modem sends an analog signal carrying your computer digital data. So by shift keying is what a modem does. We can only send analog signals, but we want to send digital data. So we use shift keying to convert that digital data to analog signal. So we saw the 3 different techniques, that is amplitude shift keying, frequency shift keying, and phase shift keying. So we change the amplitude, we vary the amplitude here, we vary the frequency here, we vary the phase here.